Hi folks. When confronted by a problem, like a lot of people, my usual MO is just to ignore it and hope it goes away. Now, this doesn't work all that often, but it seems to work often enough that I keep doing it. But after I did that last Cambridge audio CD player, where if you recall I had a bad surface mount shift register, I finally decided it's time to grab the bull by the horns and get into learning how to solder and desolder surface mount components. Now, I watched some videos on YouTube, and I'm going to link some here because some of them were truly excellent. But I had some time on my hands, and I finally decided to buy myself a trinocular microscope and some boards I'd had laying around that I was going to use, and I have been using to solder and desolder components. Also got, I don't know if you can see it over here, but I got a hot air station. I picked up a Atten H62 and a Kaizai microscope. I think it's the TX350S with the camera, and you can see the circuit board up with the camera here. And I made the usual rookie errors. I had the air turned up too high on the station, blew components off the board. I'm sure I destroyed a few trying to get them off, and I damaged a few boards, but this is why you practice on things you don't care about. So I had some donor boards I've been working on, getting a little bit better at handling these things. I had bought some tweezers, and thank God I did, because you really need a good set of tweezers. As far as the videos go, one I really enjoyed was done by a gentleman named Bruce Rain. He has a channel called Branches Creations, and he did an excellent video. I watched several times, and I highly recommend you watch if you have any interest in learning this. Plus, I find that Bruce has a very soothing voice and a good narration style, so I found it to be a really informative video, and I learned a lot from it. So I had bought the microscope, I bought the hot air station, I bought the fluxes, I bought the solder paste, and I'm coming along with it. But anyway, I'm also clearing out a lot of stuff, and as I've dug through the pile, believe me, it was a pile, I have 7 Marantz receivers I'm going to be going through. So we're going to pop the first one up here today, and we're going to go through all 7. I bought them from a gentleman who had the skill to fix them, but he simply had more stuff than he was ever going to get around to, plus was starting to suffer from some health issues. So we're going to go through those 7 Marantzes, and I just wanted to talk to you a little bit about this, because this is a new direction for me, so to speak, and it's been a lot of fun. A little frustrating, but a lot of fun. So up with Marantz number 1. Okay, so the first thing we got up here is the Marantz 2252B. I probably got maybe 4 of these and 3 2265Bs we're going to be going through. So I've got it plugged into the dim bulb tester, and something's going on. Okay, and the other thing I noticed when I took this out is we got a problem with this volume control. I have another one that the volume control is completely sheared off. This one is real floppy, so we're gonna have to take the cover off and take a look at this and see what's going on. Hopefully the circuit board's not broken, but we'll know more once we get the cover off. Okay, so I was wrong about PCB being cracked. I think these guys all mount on the common PCB. I don't have the bottom off, but this is a standalone pot, and I just had to tighten the nut back here, so now that's nice and solid. So I don't know what's going on with the dim bulb, but I don't think it's coming out of protection, so I'm going to check for any DC offset. Now, you may have seen procedures where you check DC offset at the speaker terminals, but if your amplifier is stuck in protection, you can't do that because that circuit is open. That's the function of the relay. So we're going to have to check right on the PCB and see if we can figure out if we have some problems here or not. Okay, I've still got on the dim bulb tester. I've got the black lead of the DMM tied to ground, and we are going to check at one of these emitter resistors, doesn't matter which one, just one in each channel, to see if we find offset. So if I look here, we have very little. That is in the millivolt range, so we're looking at about 20 millivolts. And if we look at the other channel, and of course the lead's right in the way of the meter, but we got about negative 20 volts of DC offset, which is why it's not coming out of protection. If you recall from previous videos I've made, when an amplifier is in protection, there's one of two scenarios. You have a problem in the amplifier, or you have a problem in the protection circuit itself. Occasionally the power supply will affect one or both of those. In this case, it looks like we got a problem with one of these channels. So I'm going to take a look and see if we have any bad outputs and take it from there. All right, well, while I was taking voltage checks, I heard this thing click out of protection, so I decided to hook it up to the distortion analyzer and scope and see what was going on here. So I'm going to turn this on now. And if you look at the meter, you could probably see glare on there, but you can see the DC is just, the output is just dancing all around here. And if we look at the scope, you can see the same thing. That one channel has got all that noise on it. In fact, if we listen to it, it should exhibit itself as a pretty noisy crackle. Okay, so it will eventually throw it in and out of protect. And it's usually caused by these differential transistors in the front end. These guys here, if we look at the schematic, that's what they call the long tail pair or differential pair in the front end. And that's usually what causes this. I don't know why I was getting that DC consistently before, but it may have been this. I'm going to try to cool these down and see if that stops our crackle. It does change it. I couldn't get these to cool down enough, but I'm going to change those out and that should stop our crackling. Okay, so I replaced them in both channels because it was just a matter of time before these get noisy too. I don't believe they use any of the same type of transistor on this board, so I just changed those out. It necessitated unwrapping some of these wires and also taking off the leads from the filter capacitors that go right onto this board. But once I did that, I was able to lift this assembly up and get underneath it. Other than that, it would have been taking all these transistors off and still unwrapping some of these wires to get it off the heatsink. So I just left the heatsink on and just tilted the whole thing forward. Worked out fine. I truly detest working on things that have this kind of access issues. But in any event, if we turn it on now, it clicks out of protection and there's no more noise. And if we turn it up, we can get, let's see, yeah, we're getting 42 and 50 watts. If I clean these controls, that imbalance should clear up, and it has to be pretty egregious before you even notice it. But anyway, this looks like this part of the problem is taken care of. I still have to go through the rest of the unit and make sure everything else works, but you got to be able to get out of protection before you do that. Okay, so I took a look at this at the tuner, and there's a problem there. The phono stage checks out okay, but if you look at the tuner, left channel is good, right channel not so good. See here, if I go to, oh, I'm sorry, this is mono, so it's very weak, as you can see. If you look here, this is right only and this is left only. So the left channel has much stronger output. Now I took a look here at the schematic, And coming out of the modulator chip, it looks okay. Going down here, I believe I checked the outputs of these two resistors. They look okay. We may have a problem with one of these electrolytics, or maybe one of these couplers here and here. I looked at the bases of these transistors here that come out of the low pass filter, and one of them's weaker. So there's something in here we have to take a look at. So I'm going to get the scope probe out and see if I can isolate where the problem is. Okay, so I found the problem in the FM. I did some signal tracing through here, and just to give you an idea, I'll show you on the schematic afterwards where I can stand it up and point things out. But if you look at it now, if I go to, that is right equals minus left, you see they're 180 degrees out of phase. Right only now looks good, left only now looks good. And this is mono. So the generator looks good now. I'm going to turn the RF off and pull in a radio station that's fairly strong here, so I don't have to bother hooking up an antenna. Okay, that looks probably tuned. The FM light isn't working. Usually if the light doesn't work, you don't get stereo. If you look here, we definitely have a stereo signal. This is what a mono signal looks like. I have this scope in XY mode, and you might have seen tuners have scopes like this. That's mono, that's stereo. So I know I'm getting stereo out of here now, and both channels are balanced. And I'm going to turn this off, set the schematic up. We'll talk briefly about what I found and how I found it. Okay, so this is basically the whole FM section here. And I worked my way backwards through it. Tuner front end is over here, and this is our FM stereo out. And this is where either mono or stereo are going to come out of. You have a low pass filter, and you have a transistor for each channel amplify. So I went back up to this IC here, which is an HA1196, and I got a printout of it, and it showed me, let's turn this noisemaker off, that my left out is pin 4, my right out is pin 5. So armed with that knowledge, I went to pin 4 and 5 on here, and I saw a good FM signal. Now it's not exactly FM, it's partially demodulated, but they still haven't gone through the low pass filter here yet. So I checked here and here, they were equal, and then I traced them out, and they go through this resistor here and this resistor here, down through capacitor here, into the low pass filter, out of the low pass filter, through these capacitors, through these resistors and capacitors, into the bases of these transistors. And I did see a mismatch here and here. So I thought for sure one of these coupling caps were bad, but they check good. These are 0.47 microfarad electrolytics, and they were fine. Didn't see any problem there. But these transistors are 2SC1344s, and they are on a replace on-site list for being noisy. Since I already found noisy transistors in here, I replaced both of these, straighten the whole problem out. I had inadvertently pulled and checked these 4.7s, and they were fine. Very, very unusual to find bad capacitors in these Marantzes, even as old as they are. They're still in really good shape. It's kind of shocking, but there it is. Anyhow, once I replaced these, RFM started working again, and I'm just going to go through quickly, check out everything else, but I believe this unit is done. And if it is, I will come back and sign off. All right, so I checked all the AM. The AM's fine. I just took a little bit of time here to change out the FM stereo lamp, so it works now. And I replaced all the dial lamps because they were all gone. So I'm going to button this one up. I've got 7 of these. I'm just going to try and see if my friend Steve wants to pick them up for me. I'll give him a good deal, get all 7 of them. I'm tired of trying to sell this stuff, trying to get rid of stuff. And that's all I got to say about that, folks. So Sorry to keep everyone waiting so long. I got a lot going on, but as always, I thank everyone for watching, and I like giving back to the community that's given me so much. Thanks a lot.